We've done enough of these guys that I think we already know how to do all of them. I don't think it's going to be an issue at all. So I guess let's get right into it. Example 1, in the figure below and to the right, below and to the right, and an altitude is drawn to the base of an equilateral triangle. So this is what you call an altitude, that guy right there. Triangle ABC, if AC is 13, so they're telling me that AC is 13. Find C, the length of the altitude. All right, so I'm gonna go ahead and outline this red triangle right here, guys. So that red triangle that I drew there is a 30, 60, 90 triangle. And I guess I should put the little degree symbol. And if you remember, n squared root of 3, and 2n is a formula for letting me know how that triangle behaves, the length. So that 13, look, that 60 degrees is to that 13. Oh, no, it isn't. That's a lie. The 13 is AC, so that's my hypotenuse. There we go. So now we're right. So they want to know what this height is, C. That's what they want to know. So they want to know this guy, question mark. So here's what we're going to do. We're going to find n. So we have 2n equals 13. Divide by 2, n equals 13 over 2. And now that I have that, go ahead and multiply by the square root of 3. So 13 over 2 times square root of 3. And they probably left it like that, guys. And there it is. That's it. If it was an even number in the top, then you could reduce it. But it's not. It's 13, so leave it alone. And that's it, guys. Pretty straightforward, or no? Okay, not everyone at the same time, guys. It was easy, right? Or no?
Yes.
Okay.
Yes.
Awesome. All right, so we have a length here, AC is 9, and they want to figure out what X and Y is. Again, it's the same thing, guys. It's a 30, 60, 90 triangle. And in a 30, 60, 90 triangle, you got n squared root of 3, and 2n. And we're doing the same thing again, exactly the same. So that, oh, why did it zoom in like that? So this right here is 60 degrees, so that 9 is my long leg. So I'm going to write n square root of 3 equals 9. So now I want to get n by itself, so I'm going to divide by square root of 3. And I'm going to rationalize it because UH probably rationalize it, guys. So 9 square root of 3 over 3. So 9 divided by 3 is 3. So 3 square root of 3. That's what y is, because y is the short leg. So now to get the long leg, I just multiply by 2. So 3 square root of 3 times 2 is 6 square root of 3. And there it is. You found X and Y. So what did we do? All we did was we set the n squared root of 3 equal to 9. We solved for n, and then whatever n was, that was my short leg. That was that guy. And then from there, we just doubled it to get the hypotenuse. All right, we're good. Let's keep going. Suppose that theta is an acute angle of a right triangle, and that tan is that. Find sine and cosine. All right, so first draw a right triangle, not to scale. NTS is not to scale, guys. So here's my right triangle. There's my right angle there. There's my angle. So tan, remember that tan is opposite over adjacent. So this must be 2 square root of 3, and this must be 5. So before I can find sine and cosine, you need to figure out the hypotenuse. So to figure out the hypotenuse, just do good old Pythagorean theorem. 2 square root of 3 squared plus 5 squared. So let's see what this is. Let's see if we can do this by hand. 2 times 2 is 4. Square root of 3 times square root of 3 is 3. 4 times 3 is 12. 5 times 5 is 25. 25 and 12. 25, 35, 37. Nope, 37 does not break down. Leave it at square root of 37. They want sine. All right, here's sine. Sine of that angle is opposite to square root of 3 over hypotenuse, square root of 37. I'm going to rationalize it because UH probably has it rationalized. So sine theta equals, and let me see what that is. 37 times 3, that's 111, and the square root of 111 Nope, doesn't have a square root. 2 square root of 111. Doesn't have a perfect, nothing factors out. So there it is. That's sine. Does everyone understand how I got that, guys? Is that a yes? Okay. I'm going to do the same thing for cosine. 5 over square root of 37. And I don't know why my laptop is being so glitchy today. All these wavy lines everywhere. 5 square root of 37 over 37. And there it is. That's it. Let me see. It's having issues. Now, right there, it looks like it's straight, but I see a whole bunch of squigglies everywhere. Yeah, see? Squigglies. That's fine. Suppose theta is an acute angle of a right triangle, and that secant is that. Find cosecant and tangent. All right, if this bothers you, just turn it into cosine, guys. Remember that cosine theta is the reciprocal of secant. So if it bothers you, turn it into cosine. So here's my right triangle. No squigglies there. And cosine is adjacent over hypotenuse. So to figure out this leg, you're going to have to do square root of 13 squared minus 7 squared. And we get, let's see, square root of 13 squared minus 7 squared. And we get square root of 120. 120 breaks down 4 times 30. And the square root of 4 is 2. So 2 square root of 30. All right, let's do the tangent one first. Tangent theta. Tangent is opposite over adjacent. 2 square root of 30 over 7. And now let's do the cosecant one. So cosecant is the reciprocal of sine. So sine would have been 2 square root of 30 over 13. So now do the reciprocal. So it's going to be 13 over 2 square root of 30. Now you don't want to see the square root of 30 down there. So let me go ahead and rewrite it. So cosecant theta is 13 square root of 30 over, let's see, 2 times 30 is going to be 60. And I don't think 13 over 60 reduces. So nope, it doesn't reduce. There it is. So there's my cosecant. This is my tan. And I don't see any errors, so I think we're good, guys. All right, example 5. These are pretty basic. Convert the following radians to degrees. Just multiply by, let's see, this is going to have to be by 180 over pi. And when you do that, let's see, well, you guys already know this one. 7, 6, that's at 210 degrees. Yeah. And then 3 pi over 2 times 180 over pi, that's going to be 270 degrees. And 11 pi over 12, ooh, I don't know that one. It's pretty close to pi though. 11 over 12 times 180. So 165 degrees. And there it is, guys. All I did was multiply by 180 over pi, so maybe I should have showed that. Times 180 over pi, 165 degrees. So there it is. Radians to degrees, just multiply by 180 over pi. All right, quick minute lesson on arc length. So all these, central angle and area of a sector. So all this is stuff that you should have done in geometry. So what is arc length? Well, I guess let's start with central angle first. So central angle is this. This is called the central angle. It originates in the center. And then what is called an arc length. This here in black is arc length. And they usually use the letter S. Usually uses letter S. And then you know the circumference of a circle. Circumference means the whole revolution there. One revolution is 2 pi times a radius. And sector, so what's a sector? A sector is all that in blue. Remember that area of a circle is pi r squared. So area of a sector, so let's talk about how do we get area of a sector and how do we get arc length. So area of a sector is going to be, you can just do a proportion, theta divided by 2 pi, because remember 2 pi is 1 revolution. If you're in radians, by the way, this is if you're radians, times pi r squared. So notice the pi's cancel out, and you get theta r squared over 2. This is if you're in radians. Now, how do I get arc length? All right, arc length. Let's see, you're going to do the same thing. Theta over 2 pi, and then you're going to multiply. This theta over 2 pi is just a ratio. It's just like a percentage. And then you multiply by 2 pi r, and notice the 2 pi's cancel out, and you just get theta r. This is only if you're in radians. Let's do it in degrees. If you're in degrees, area of a sector, let's see, theta over, how many degrees is 1 revolution, guys?
360.
So theta over 360 degrees times pi r squared, nothing cancels out. So just leave it like that. Theta pi r squared over 360. This is if you're in degrees, by the way. So theta here on this one is a degree. And your arc length is going to be, again, it's going to be theta over 360 times 2 pi r. So let's see, we're going to write it 2 theta pi r over 360. I guess you don't have to, you could just write it like this, but. Or you know what? Let's reduce it. 2 goes into 360 180 times. I reduced it, guys. And I took out the degree symbol only because we're talking about arc length. The degree symbols cancel out anyways. The theta with the degree and the degrees. So we're talking about a unit of length, meters, inches, centimeters, whatever it may be. All right. Do we feel okay, guys? This is actually very popular on the SAT, by the way. And you can see why radians is so popular. Look how easy that formula is. Excuse me, theta r. Find the arc length when theta is 240 degrees and r is 6 centimeters. All right, we have it in degrees, so we're going to use this formula. 240 times pi times 6 divided by 180. 240 times 6 divided by 180. And you probably don't need a calculator. You probably can figure it out without a calculator. 6 goes into 18 3 times. 6, 12, 18. Well, 6, that's, yeah, so 180 is 30. And then 24 divided by 3 is 8. So there it is, 8 pi. 8 pi centimeters is the arc length. If you need a visual, what are they trying to do? Here's your visual. So here's the center and 240 degrees. Let's see. So we just calculated. Actually, I should use a new color, right? We calculated this in green, guys. That is 8 pi centimeters. If you want to know what 8 pi is, just go 8 times 3.14, and that will tell you that it's about 25.133 centimeters. And there it is, guys. Pretty straightforward, nothing crazy. Did the visual help or did the visual not help?
It helps.
Okay. So this one says, find the arc length when theta is pi over 4. Now we're in radians, so now we can just use our little formula. So when r is 9, so I'm going to come back and I'm going to look at my arc length for radians, and it just says theta times r. So I'm going to write S equals theta times r. So pi over 4 times 9. 9 pi over 4 yards. How does that look? And what you just count, well, I guess I should change the color. What you found is this distance in red. The radius is 9. Very cool, guys. Happy face. Ooh, look at this one. This one's different. Find the perimeter of a sector of a circle with central angle 7 pi over 4 and radius 10. So this says the word perimeter. So that changes the game completely. Here's my circle. Let me see if I can draw this here to the left here. Oh, that's a nice circle. In the center, let's see, and I'm revolving 7 pi over 4, 4, 8, 7. So I'm going to be rotating all the way to like right here. That is 7 pi over 4. Let's see, I need to have a radius. That radius is 10. All right, I want the perimeter of this circle, of this with the central angle of that. So everything in red is what you're going to calculate. You're going to calculate that. That's already 10. You're going to calculate the arc length of this. And then you're going to calculate that distance. This is actually a very popular question on the SAT. They ask this question often. Sometimes they say it's a farmer. Well, I don't know. It can be questioned many different ways. Let's just continue. Let's just answer this question. So if I want to know what the perimeter is, I'm going to create my equation here. Perimeter is the radius added twice, 10 and 10. 10 plus 10. Does everyone see where I got those numbers from?
Yes.
Plus the arc length. The arc length is going to be 7 pi over 4 times 10. Now, let me group them. I'm going to, for good notes, that right there is your arc length. And then that was your radius. And then that again is another radius. And there it is. That's my perimeter. It's very similar to circumference, but circumference is a property of a circle. This is not a circle because I have straight lines right there where the radius is at. So now we call it a perimeter. So there it is. We're going to add them all up. Perimeter equals 20 plus, let's see, 2 goes into 4 twice. 2 goes into 10 5 times. 7 times 5, that is 35. So 35 pi over 2. And I need units, feet. There it is, guys. I think we did everything correct. I don't see any mistakes. There it is. If you wanted to know what that is, if you want to know what that number is, I can just type that into my calculator, right? So 35 pi divided by 2 is 54.977. I'm going to add 20 to that. And that is 74.977. 74.978 feet. UH is probably going to have this answer. Are we still okay, guys?
Yes.
All right. Don't worry, we're almost done. I think we just have a few questions left, really. It looks like a lot, but it's not that much. Find the area of a sector with an angle of 135 degrees and radius of 6. Okay, so here's my little circle. Let's see, 135 degrees. So that's going to put me somewhere like right there. Oh, I don't want an error. I don't want an arrow. Sorry, I want to close it. So they want me to figure out this sector. This is 135 degrees. Common problem. So here we go. Area equals 135 over 360. This is like my proportion, guys. This is like my percentage. So this is like percentage. Something over something. Times pi times 6 squared. So I'm just going to type that into my calculator, guys. 135 over 360, that's 3/8 times 36. And I get 27 pi over 2. And on the units, square centimeters. And there it is. Don't say centimeters squared, guys. Say square centimeters. And in case you're wondering, why do you say square centimeters and not centimeters squared? If you look down at your floor, if you have tile, and you count the tile pieces, like, so just think about tile, like tile. Do you say, oh, those are 5 tiles square? Like if you count 5 tiles or if you count 6 tiles? No, you don't say that. You say you have 5 square tiles because those are squares. It's a 1 by 1 or 1 foot by 1 foot or whatever the dimension may be. So that's how you know what to say. So you say square centimeters, not centimeters squared. Anyways, yeah, let's continue. A sector of a circle has a central angle of 7 pi over 4 and an area of 63 pi over 8 square feet. Find the radius of the circle. Ooh, I like it. I like this question, guys. I'm really enjoying it. I typed this question out, by the way. I'm pretty sure I took the question from a UH type of quiz here. So let's see what they want. They want the radius. And so here's what I have, 7 pi over 4, so that's going to be something like that. And this area of all this, that area is 63 pi over 8, and they do not know what the R is. All right, so area equals, and if we come back over here, this is a radian. So we come back up here for radian, theta r squared divided by 2. So here we go, guys. 63 pi over 8 equals 7 pi over 4 times r squared, we don't know what that is, divided by 2. So we can do keep, change, flip if you want. This is like 2 over 1. So you can say 63 pi over 8 is equal to 7 pi over 8 r squared. Did I lose anyone? Guys, is everyone okay?
I'm a little bit confused.
Okay, all I did was, this is like, I just did this, A divided by B divided by C. So this is like A, this is like B, and forget this R squared is even there. And that's like C. So I'm not saying C over 1. I can just do keep, change, flip. A over B times 1 over C. That's just A over BC. See? So all I did was I brought that 2 up. I just brought the 2 there, and I just multiplied it. 4 times 2 is 8, and that's why I have an 8 in the bottom. I don't know if that was part of your confusion. This is my area of the sector, so I just plugged in. The 7 pi over 4 is your angle, so I just plugged in. Does that make sense?
Yes, I never understood that, like, the thing with the fractions, and now I do.
The keep, change, flip?
Yeah, because I would do it like the A over BC, but I didn't understand why until now.
Oh, you should always ask, miss. I'm sure the teacher would have explained it. But that's okay. But now we're learning, and I'm happy that you now know it. So you, miss, are winning at life. You should go celebrate. I'm going to multiply by 8, guys. Get rid of that 8 down there. So now I have 63 pi equals 7 pi r squared. And I'm just going to divide by 7 pi. divided by 7 pi, divided by 7 pi. 63 divided by 7 is 9. So r squared equals 9. And you can already see where we're going with this. Square root. And there's my radius. Yay. Happy face, guys. Happy face. Because we're winning. Okay, these two questions, they look hard. They're not. Let's read them. A car has wheels with a 6-inch radius. Yeah, it has to be a really small car. The radius is 6 inches. This is like a golf cart. So it's probably not a car. Well, actually, they do have small cars in like the Philippines and stuff like that. But anyways, let's just keep reading. If each wheel's rate of turn is 5 revolutions per second, find the angular speed in units of radians per second. So here's what they want. They want radians per second. You don't even need this because they already tell you how fast you're going. This is already an angular velocity. So radians per second is also angular velocity. So I got to do this 5 revolutions per second. So I'm doing like a T. And in 1 revolution, how many radians are there? In 1 revolution, there's 2 pi radians. Look, the revolutions cancel out. 5 times 2, that's 10 pi radians per second. There it is, guys. What do you guys think? You guys okay? No comments?
I think we're good.
Okay.
Did you multiply 5 by 2 to get the 10 pi radians?
Yes, whatever I have in the top, sorry, I didn't explain this. I just did dimensional analysis. Whatever you have in the top, you multiply. Whatever you have in the bottom, you're going to divide by. I guess you could multiply everything in the top and multiply everything in the bottom, and then just in the very end, just go whatever you have in the top divided by whatever you have in the bottom. So I'm going to do dimensional analysis again on example 12. A car has wheels with a 9-inch radius. If each wheel's rate of turn is 6 revolutions per second, how fast is the car moving in inches per second? So now they want linear velocity. So here's what you're going to do. You're going to go 6 revolutions per second. And you're going to go in 1 revolution, you travel the whole circle. 2 times pi times radius. Does that make sense? You don't have to do it that way. There's another way. Okay, I'll do it the other way. In 1 revolution, there's 2 pi radians. You'll get the same answer anyways. And in 1 radian literally means what's the radius? 9 inches. Radians cancel out, revolutions cancel out, you get inches per second. 6 times 2 times 9. So 108 pi inches per second. If you didn't want to do it that way, you could have done it like this. Think about it. In 1 revolution, you cover how much ground? 2 pi times r. That's the circumference of a circle, guys. The circumference of a circle is 2 pi times r. So every time you do 1 revolution, that's how much ground you do. So if you wanted to, you could have just gone 6 revolutions per second. And you could have said in 1 revolution, you cover 2 times pi times my radius, which is 9 inches. And now I'm putting the word inches because that's what it is. 2 times pi times 9, that has the unit of inches. And you'll get the same answer, 108 pi inches per second. Cool or not cool? Okay. I put this in here for review. Don't try to do as much as you can of this without looking at a unit circle. Try. So I guess you can draw, like visualize in your head where negative pi over 3 would be. Positive pi over 3 is right here, but negative pi over 3 is down there. That's like negative 60. So at negative 60 degrees, the y value is going to be negative square root of 3 over 2. Do you see how we did it, guys?
Yes.
Yeah, sine of negative 5 pi over 6. Well, it's negative sine 5 pi over 6 would have been right there. And that's going to be a negative 1/2. Cosine of 3 pi over 2. Cosine of 3 pi over 2 is at 270. Cosine's the x value, 0. Try to do as much as you can without the assistance of a unit circle. So I just put this in here for review for you guys. And then here is your deal, what you got to do.